So for this problem, we have light that's traveling through the air, and then it's going to hit the surface of water, and of course the light's going to refract as it moves through the water. So we're given that the index of refraction of the water is N2, 1.331. We can approximate the index of refraction of air to be about 1. And the angle of incidence, theta 1, is 60 degrees. And what we want to find for part A is the angle of refraction, this theta 2 over here. So to do that, we can use Snell's law. N1 sine theta 1 equals N2 sine theta 2. So rearranging for sine theta 2, we have sine theta 2 equals N1 over N2 sine theta 1. To find theta 2, we just take the arc sine, inverse sine of N1 over N2 sine theta 1, which is equal to inverse sine of N1 is 1, N2 is 1.331 times sine of 60 degrees. And if you plug all that in, you should get the theta 2, or index of refraction, is 41.6 degrees. So for part B of this problem, we're given that the wavelength of light in air is 650 nanometers, and we want to find the wavelength of the light in water, because of course the wavelength of light is going to change as it moves from one medium to another. So let's look at the formula for index of refraction. N is equal to C over V. That's the speed of light over the speed of light in a vacuum over the speed of light in the medium. So if we have, and we know that V, the speed of light, is going to be equal to the wavelength of light times its frequency. But we know that the frequency of light doesn't change from one medium to another, but the wavelength of the light does. So if we take the ratio N1 over N2, we have C over V1 over C over V2, which is equal to V2 over V1. Using this formula, we now have lambda 2f, right? The frequency stays the same, but the wavelength does not, over lambda 1f. The frequencies cancel, and we're left with lambda 2 over lambda 1. Thus, N1 over N2 equals lambda 2 over lambda 1. We have a relationship between the index of refraction of the two mediums and the wavelength of light in the two mediums. And now we can just solve for the wavelength of light in the water. Lambda 2 equals lambda 1 times N1 over N2. So lambda 2 is going to be equal to, lambda 1 is 650 nanometers, so that's times 10 to the negative 9 meters, times N1 over N2, which is 1 over 1.331, and you should get that the wavelength of light in the water is equal to 488 nanometers.